Math 242, Cuesta College. I'm Joe Vasta, and we are doing 8.5 determinants. You might say, well, why are you doing 8.5 and before 8.4? You'll see, but we're going to do 8.5 before 8.4. Okay, definition. Let M be this 2 by 2 matrix. The determinant of M is AD minus BC. So the determinant is going to be just some number. It is denoted by DETM. So let's go ahead and find the determinant. What does it mean? We'll actually do some applications at the end. We're just going to figure out for this the determinants. Okay, so the determinant of this matrix, and actually let me go ahead and bring the definition in there just so we have it for this time. We would go like this. Here's the determinant of matrix A, and it is, so this is playing the role of A here, and this is playing the role of B, and there's C, and there's D, so we're going to go AD. So what is this? This is 6 times 3 minus, because that's what the formula says, BC. So I'm doing this right here, B, which is that guy right there, and then C. So what does this give me? This gives me 18 plus 6. 18 plus 6 is 24. So the determinant is a number that's associated with a 2 by 2 matrix. In fact, the determinant is a number associated with any square matrix. A square matrix is a matrix where the rows and the columns, the number of rows equals the number of columns. Okay, so we'll do determinants of 3 by 3 matrices and things like that. But we have to start off here. The determinant of, for problem 2, of B. So it's going to be AD. So I'm going to go a little faster on this. So I'm going to multiply those together. AD, so this is negative 24 minus BC. So when you multiply those, that is negative 12. And so what do we have? We have negative 24 plus 12, which gives me a negative 12. And that is how you compute the determinant of a 2 by 2 matrix. Let's go ahead and do the next problem. The determinant of a 1 by 1 matrix. Now we don't have it defined there, but I'm going to just tell you what it is. The determinant of a 1 by 1 matrix is just the entry in the matrix. So this is negative 7. So we're not going to really be getting a lot of those in the homework. So 1 by 1 matrix, the determinant is just the entry. Now here's the last one that we're going to do with that's 2 by 2. We're going to say the determinant of matrix D is, now this matrix has functions in it instead of numbers, and we're still going to go AD. So I have A, D. It's kind of weird calling those A and D, but they're in the position. Here's A and then here's D minus BC. So X ln X times 1. So let's go ahead and distribute the X there. I have X plus X ln X minus X ln X. And so it looks like these guys cancel. And what we have here is our determinant of this matrix is just X. And this is what, if you take differential equations, you'll be doing some linear algebra here. You've just computed the Wronskian of 2 vectors, whatever that means, but you've done something and that helps solve differential equations. Let's go ahead and do some more problems here. See if I can find problem 5. Here it is. Now we're going to take the determinant of a 3 by 3 matrix. Of course, if you read the book, you know, they might take a different approach. On this, I just want to do some problems and see if we can do problems correctly here. So how am I going to do this problem? Well, we didn't define how to do the determinant, and without getting too technical, let's go ahead and figure this out. What I'm going to do is I'm going to travel across. This is supposed to be an arrow. The first row. Okay. Now, when I travel across the first row, there's one other thing that we have to say, is that each number, each position in this matrix has a positive or negative position. This first top left corner will always be the positive position. And even though this 2 is a positive 2, it's still in the negative position when you're computing determinants. And then this 4 is in the positive position. And this is going to work like a checkerboard or a chessboard. So there will be that 5 is in the negative position, and then plus, and then minus, and then that 2 is in the positive position. So do you see how it looks like a checkerboard? We'll always start off with a plus in the top left corner. Okay, now knowing that, let's go ahead and compute the determinant of E without actually knowing the definition yet. This is pretty scary. So this is what you're going to do. You're going to write those 3 numbers down, but kind of space them out. So I have a 3, a 2, and a 4. Now, I have to put the positions, the pluses and minuses. So this guy's going to have a plus in front of him, and then minus, and then plus. So I did that right there. And then, to make matters more confusing, you're going to take the determinant of something weird. So like, what is this going to be? You're going to take the determinant of a 2 by 2 matrix. That 2 by 2 matrix is gotten from covering up the row and the column that contain that 3 right there. So covering up the row that contains the 3 is that, and covering up the column is that, and you get the matrix 1, 1, 1, 2. 1, 1, 1, 2. Okay, let's move on. So I'm going to go -2 times the determinant of a 2 by 2 matrix. I'm going to get that 2 by 2 matrix. So here's the 2. By covering up the row that contains the 2, and I know it's creating a shadow, and the column that contains the 2, and I have a matrix that looks like 5, 1, 2, 2. So 5, 1, 2, 2. And then you have plus 4 times the determinant of, we're going to do the same thing, we're going to cover up the row and the column that contain that 4, and I get the little submatrix 5, 1, 2, 1. 5, 1, 2, 1. So let's go ahead and complete this. The determinant of a 3 by 3 matrix will be a real number when you have all numbers in the matrix. So I have 3 times this determinant. Now I'm going to do this AD minus BC that I was doing in the other problems. I'm going to do a little faster. 2 minus 1. Minus 2 times 10 minus 2, which gives me 8. How did I get the 8? 5 times 2 minus 1 times 2. AD minus BC. And then I have plus 4. And the determinant of this little 2 by 2 matrix is 5 minus 2, which is 3. So let's see what we get. We get 3 minus 16 plus 12. And so this is really 15 minus 16, which is -1. And somehow this is going to be important, finding the determinant of a matrix. Or I'm going to pretend that it's important, and it's really not important at all. You decide. Now, here's a theorem or a rule with determinants. With determinants, it just so happens that I could travel across any row and do the calculation and get the same answer. Or I can even travel down any column and get the same answer. Now, to prove that what I'm saying is correct, let's go ahead and travel. So I'm done with the problem, by the way. I'm going to travel down this column. Whoa, okay, there's my arrow there. So this one has gotten from the orange path. And this one here. So I'm doing the problem again, and that might upset some of you. And you're like, hey, just do the problem one time. Let's see what happens. So I go ahead and write the 2, 1, 1. So 2, 1, 1. Now the 2 is in the negative position. And this middle one is in the positive position. You'll find that once you get this going, it alternates signs. And then this one down here is in the negative position. So this is going to be times the determinant of the row and column that you get when you cover up that 2, which is 5, 1, 2, 2. So 5, 1, 2, 2. And then on this one here, we have determinant of the row, the matrix you get when you cover up the middle row and the middle column, which would be 3, 4, 2, 2. And then this one is the determinant of what you get when you cover up this one right here, which is the last row in the middle column, which would be 3, 4, 5, 1. 3, 4, 5, 1. So let's go ahead and crank this out. We have -2 times, and I'll do this one just verbally, 10 minus 2, which is 8. Then we have +1 times 6 minus 8. That is -2. And then we have -1 times 3 minus 20. That is a -17. You see that -17 there, and you're like, ha, Vasta's wrong about this. But let's see what we end up getting. We get -16 minus 2 plus 17. That's -18 plus 17, which gives you -1. These things right here, when you figure out, when you cover up a row and column and figure out the determinant of that submatrix, those are sometimes called minors. Okay, and if you read the book, you'll learn something called cofactors. That's the minor times whether it's a positive one or a negative one. So when you look at the book and you look at books, they always make this sometimes a little more complicated than it really has to be. Now, I still haven't answered, like, why are we doing this? Well, the main reason is this is a math class and you have to know, but there are applications, and we'll show you an application at the end. One application I can tell you that I'm not going to show you is something called Cramer's rule, which some teachers cover in this class. And you can use determinants to help you solve linear systems. But not all linear systems can be solved using Cramer's rule, and that's why we learned the method that I showed you with the augmented matrix. Let's go ahead and do another problem where we are to find the determinant. So this is the determinant of F. Okay, so we can travel across any row or down any column, and probably a good one to pick, maybe, with the least amount of work, is this one right here, because that has some zeros there. So watch this. This is 0, 2, 0. And this first 0 is in the, let's see, plus, minus, plus. This is in the positive position, and then this is in the minus position, and this is in the plus position. Now, when I go to compute, like, the determinant of this submatrix here, a submatrix is just part of a matrix, 4, 3, 2, -3. It doesn't even really matter. I've kind of wasted my time writing that because this right here is just 0. And so will this be. So I'm not even going to write down like what we were calling the minors. All we have to do for those guys, all we have to do is write out the determinant of this middle guy here. And this middle guy is gotten by covering up the row and the column that have that 2 in it. So it looks like it's going to be 1, negative 2, 2, negative 3. Okay, let's continue on this. This is going to give me negative 2 times this determinant. I'm going to go AD minus BC, so this is negative 3 minus a negative 4. That's negative 3 plus 4, which is 1. So this gives me negative 2 as the answer. You didn't have to go down that last column. You could have traveled across the first row. You would have got the same answer. So that is how to compute a determinant. Now we're going to go crazy, and we are going to compute the determinant of a really big matrix. Actually, before we do that, okay, so I take that back. I want to go back to problem number 1. Where is it? Got all these pieces of paper here. So I'm going to do this in purple. We could actually use this definition to compute the determinant of 24, the definition that I showed you, not AD minus BC. So let's just go ahead and do this. And not that we would do this on a 2x2 matrix. But I always like to show this because this is how the book will do this at first. This is how they define it. So we could, so for those of you who are just doing the minimal thing in this class, you might want to skip ahead. I'm going to travel across the first row. I'm computing the determinant of A. So 6 is in the positive position, and negative 3 is in the negative position. And now what I'm going to do is I'm going to compute the determinant of what I get when I cover up that 6, the row that has the 6 in the column. And when I cover those up, I just get 3. The determinant of that 1x1 matrix 3 is 3. And when I cover up the row and column that contains the negative 3, I just get 2. And look what I get. I get 6 times 3. And then I have minus a negative 3 times 2. Isn't that exactly what I have written up there? Which gives me 24. So the bottom line is, if you're like, well, what should I get out of this purple part? Nothing. The thing to get out of this is to go AD minus BC when you have a 2x2 matrix. Okay, now let's go ahead and do that problem that I put up, number 7, which is a 4x4 matrix. We are almost done with this section, by the way, and all you do in this section is compute determinants. So let's see what we have here. It's 4x4 matrix. Let's compute the determinant. How do I compute the determinant? I decide to travel on any row or column. You know what? I'll just go ahead and do this third row right here. I'll travel there. Now I think you only get like one 4x4 in your homework. Or maybe a few, I don't know how many you get, but make sure you know how to do 4x4s. So when I do this, I'm going to go ahead and write out those numbers I have. So this is the determinant of matrix G is 0, 1, 2, and 0. Now, this 0 is in the positive position, plus. This 1 is in the negative position. Remember, it's like here's plus, minus, plus, minus, plus, minus. So this is the negative position. The checkerboard applies to this as well. So let me draw the checkerboard. Then we have plus, minus, and then we have minus, plus, minus, minus, plus. So that's how it works with these matrices. So then, let's see. Oops, I did this wrong. Okay, so this is so that gives me a minus, this one's a plus, and that one's a minus. Now these guys right here are just 0, so we don't care about those anymore. What we're going to care about is this, the determinant of what you get when you cover up this 1 right here. And what do you get when you cover up that 1? You get a, I don't know how to do this. Here we go. I'm sanding the paper there. I end up getting 1, negative 1, 2, I don't know if you can see that, 0, 2, 0, and negative 1, 3, 0. Okay, so that's what happens when I cover up that 1. And I'll just kind of double check what I'm getting. Wait a minute, so I covered that up. And I get 1, negative 1, 2. Good job. Okay, so I did a terrible job. So let me go ahead and, this is why I double check things. Okay, so I'm covering up the row and the column that have that 1 in them. And so I'm trying to find something temporary that I can use. Oh, here it is. And then I mucked it up because I was like thinking of the nail file going, oh, well, that's not really cool to have in a math video. So let's cover up, see the column that contains the 1. And I'm just using good old-fashioned scissors and a post-it note. I don't know why we have pink post-it notes in here. And so there it is. 1, negative 1, 2. And then I have 2, purple pen, 2, negative 2, 1, and then I have negative 1, 3, 0. And then I'm going to do the same thing with the 2. So I'm going to cover up the row and the column that contains this 2 right here. So I cover up that row and this column. So this gives me 1, 0, 2, 2, 4, 1, negative 1, 2, 0. Okay, now it looks like this problem has turned into 2 problems. Okay, so now I'm going to go ahead and travel maybe down this column here for this one. So I have negative 1, and then let's just go like this. I have 2, which is in the positive position. Now, it was in the negative position on this one, but now you go ahead and, this is plus, minus, etc. So that you have 2, which is in that position, and then I have 1 right here. So this is going to be 2 times the determinant of 2, negative 1, 3. And then this is going to be minus 1, because minus is in the negative position on this matrix, times the determinant of, cover up the row and column that has that 1, you get 1, negative 1, 3. Woo, this is a traumatic problem. Then I have plus 2, and then I think I'll decide to go maybe on the first row here. So I have that. Okay, so I have 2. The 1 and the 2 are in positive positions. So this is going to be the determinant of the matrix gotten by covering up the row and the column that contains that 1. So 4, 1, 2, 0. 4, 1, 2, 0. And then this is going to be 2 times the matrix gotten by covering up the row and column that have that 2 in it. So 2, 4, negative 1, 2. Okay, we're going to have to go on to another piece of paper on this one. Okay, so this is negative 1. And then we have 2 times the determinant of this 2 by 2 matrix. This is 6 minus 2, which is 4. And then I have minus 1 times the determinant of this 2 by 2 matrix. This is 3 minus a 1, which is 2. Then I have plus 2 times 1 times the determinant of this matrix, 0 minus 2. And And then this one's going to be plus 2 times the determinant of this, which is 4 minus a negative 4, or 4 plus 4, which is 8. Okay, so I'm just doing some arithmetic now. I end up getting negative 1, and we have 8 minus 2, plus 2, negative 2, plus 16. So I have negative 1 times 6, plus 2 times 14, negative 6 plus 28. 28 minus 6 happens to give me 22. 22 is the determinant of this original matrix. So there it is. 22 is the determinant of that matrix. Let's go ahead and do another example of determinants. I'll take the determinant of H. So the determinant, now look what H has. The determinant of H, it has an I, J, and a K. If you take a physics class, this is actually doing something called the cross product of two vectors in 3 space. Those two vectors being 1, negative 2, 0, and 3, 0, 1. Now if that didn't make any sense, let's just go ahead and do this. The I is in the positive position, the J is in the negative position, and the K is in the positive position. So this is going to be I times the determinant of negative 2, 0, 0, negative 1, minus J times the determinant of 1, 0, 3, negative 1. And how am I getting this? I'm covering up the row in the column that has the J in it. And then K times the determinant of 1, negative 2, 3, 0. So let's go ahead and compute this. This is going to give me a 2 right here because I have 2 minus 0. So this is 2i. And then this is going to give you a negative 1. So this is minus j times negative 1. And then this is going to be plus k times 0 minus a negative 6. So this is going to be 0 minus a negative 6. So this gives me a positive 6 here. Okay. So that's what I have, AD minus BC. AD minus BC. Okay, so what am I getting for my final answer? I'm getting 2i plus j plus 6k. And, you know, in physics you would have to put little hats on those i's, j's, and k's, but you don't have to do that right now. And that is what your final answer is. So this is a... this is an application, even though it's kind of like above, you know, above some of your heads, an application of the determinant of a 3x3 matrix. So we're going to go move on to the next example, and I'm just double checking some work that I had here. Okay, we'll move on to the next example. This is our last example. It's an application. You're not going to have to do this in your homework, but the application says, find the area of a triangle. This is not a right triangle. It almost looks like it. And you have a triangle that looks like this. You're trying to find the area. Okay, now I know the area of a triangle is 1/2 base times height, but it would be really hard to grab that information from this. I'm not going to get into why this is true because you need some trigonometry, you know, I mean, there's a proof behind this, but the area of any triangle that is put in that is put on a rectangular coordinate system happens to be this. It's going to be 1/2, and then we have the absolute value of the determinant of the following 3x3 matrix. So the following three, what we're going to do is we're going to put these points. So we're going to put the point 1, 2, because there it is, and then 2, 4 right there, and then 3, 1 right there. And what we're going to do for the last column is, and this is where you'll always do this, but this is where, like, if you're interested, you would have to go find a proof of this. You put the 1s. So you just put 1. So if these were 3 different points, you would put the 3 different points there, and you'd put 1s there. And so when you do this, you end up getting, now because this is just an application, you can do this determinant on your own. You will get, and you should probably see if you can figure this out on your own. You take the determinant, you will get -5 of the determinant. So it looks like the area of that triangle there is 1/2 times 5, because the absolute value of -5 is 5. The area is 5/2. Okay, and where I'm leaving it up to you to see if you can verify that the determinant of that matrix there is -5. So that ends 8.5. Do your homework and have a good day.